Good afternoon, everybody. ASFPM 2021 Showcase attendees. Welcome to our IBM Wednesday Wrap-Up Showcase. Today we have two great presentations to share with y'all. The first one will be by Jack Paxton on our current status and update around the automated map production effort that's ongoing with FEMA. And the second presentation by Dr. Johannes Schmude, who will cover our IBM PAIRS Weather Operations Center and the opportunity to do things with geospatial analytics. We also have helping us Ashley Saxon. She will be with us during our Q&A sessions. Ashley is a senior consultant at IBM and supports our Homeland Security and Justice industry teams as a strategic advisor. And hats off to you, Ashley. She's been helping us throughout the ASFPM conference, and some of y'all may have met her in our booth. And then finally myself, Rob Harden. I'm the IBM Industry Account Lead for FEMA and Coast Guard. I wanted to kind of bring up a few little things about ourselves here. Not many people on our IBM team know that I'm a little bit of a weather junkie and a flood junkie myself. Years ago, I even completed what is now, I think, the National Weather Service Skywarn Storm Spotter training for amateurs with my son. So being from the South originally, during disaster season, I typically jump on the National Weather Service site, FEMA's site, the National Buoy Data Center site, and then the National Weather Service River Gauge site, and do a lot of cross references. And it's been amazing over the years to have done that somewhat manual, and then get into a little bit about what we'll show you today and how all that layers into itself. And I think to myself, wow, I stayed up for hours in the middle of the night tracking a hurricane for fun when I could have, pushed a few buttons and had all the answers there. But we're looking forward to showcasing some great things we're doing with FEMA and a lot of the stakeholders. As many of y'all know, IBM's been around for a long time. We've been supporting FEMA for about 30 years now. Many of its stakeholders at the state and local level for longer than that. Right now, we do have ongoing disaster work supporting states like North Carolina, Texas, New York, and California. And we know that, with the ever-changing climate right now, forcing us to adapt our ways of thinking and our ways of doing business, we're going to be here with you and your partner on that journey and help try to innovate and support all the great people that attend the show. So right now, I'd love to turn it over to our first speaker, Jack Paxton, and he's going to go over our automated map production. Jack is on our Agile development team. He leads one of the teams there with our RiskMAP Customer and Data Services program. He's been on the program for a while now. And outside of his love for AMP, he also spends some time every year skiing in the mountains. So he's, likes the frozen floods, I guess. But Jack, I'll turn it over to you and go through your presentation.
All right, thanks for the introduction, Rob. Give me 1 second and I will share my screen here.
Yep, and while Jack's sharing his screen, please everybody, if you have questions or comments, please let us know along the way as Jack's giving his presentation, and we'll get those answered for you. Thanks, Jack.
All right, well, hi, everybody, and good afternoon. My name is Jack Paxton, and as Rob mentioned, I work for IBM. I'm on the RiskMAP CDS program, and I was one of the development team leads for this automated map production project, which I'm really excited to talk about today. So for starters, what is automated map production? Just like the name implies, it's a tool that provides automation for a process that before this was largely manual. So what AMP really is a set of processes that enables the automatic production of firm panels and a firm index. And AMP is able to produce these products based on the data that's provided in the firm database. AMP uses the Mapping Information Platform, or the MIP, And that's another large application that the CDS team maintains. And it uses that as a mechanism for storage of the products that it produces. AMP was partially inspired by some of our other geoprocessing services or print tools that we released earlier on and that are available on some of our national viewers. There is a MSC dynamic map for MET tool, which allows you to print a small subsection of a firm panel in a kind of nice organized template. And then we really, for this project, built on the concept of the NFHL full firm print, which you could find in the NFHL viewer. So we really optimized that concept and applied it so that we could automate this process of producing firm panels. And as far as the timing is concerned, at last year's conference, I gave a short presentation on AMP. And at that point, we were really just kicking off the project. We had started to generate some of the first sample panels, and we were really focused on just the draft life stage of development. And since then, we've come a really long way. We've optimized a number of aspects of the process and of the actual end product itself. And today, AMP is out there, it's deployed, and it's generating panels and indexes for all the life stages of product development. So for draft, for prelim, and then for the pending panels that eventually become effective. So a little bit more information and some key points about AMP. AMP was really designed with simplicity in mind. So we tried to keep it as straightforward as possible. And all AMP really requires in order to run is just the underlying GIS data that's uploaded in the firm database, that collection of shapefiles. And it requires that the user runs the DFirm verification tool, or DVT, which is the QC that runs against the data. And that has to pass in order for AMP to be triggered. We were very intentional about making limited changes to the MIP workflow. So again, AMP is really a back-end process. It's a lot happening behind the scenes. And the way that a user would interact in our MIP studies workflow is largely the same as it was prior to deployment of AMP. I mentioned AMP was expanded from where we were at this time last year. We were only at the point of producing draft panels. Now we have that being produced for all of the life stages. And then in addition to generating firm panels, we also generate a firm index product for each life stage as well. So how does AMP actually work? The first step that I mentioned is it has to have the underlying shapefiles. It has to have the data in order to generate the panels. So that's the firm database upload activity that you would typically see in the MIP. You have your draft data capture, your prelim data capture, and your final mapping data captures. And then just as before, you have to run metadata validation against the XML file that's uploaded there. And then DVT will run and will QC the actual GIS data. And once DVT passes, that is the catalyst for AMP to kick off. So AMP pulls in the data that was uploaded. It converts the data to a modernized version of the firm database schema. And then we leverage an ArcGIS Pro print service that we built and that basically runs through the full set of panels that are in the SFirmPan table. And it kicks out a set of firm panels and a firm index, and it populates those files underneath the task that the data was uploaded to on File Explorer. And on File Explorer is where the user could navigate and review those files that are generated. So here is an example of what your data capture screen would look like just prior to AMP running. So you can see the user chooses their firm database zip folder. In this example, they've uploaded it already. You can see the passing metadata validation status and additionally the passing DVT validation status. And with that passing DVT status, AMP has now been triggered and is running behind the scenes. One point worth mentioning here is that the MIP enables DVT to pass organically. So it can run through the initial QC and pass, or users today can request a bypass of DVT if there's certain checks that an exception applies or that should be overlooked for that particular data set. And for AMP, it doesn't distinguish between what was bypassed or what passed normally. It just has to have a passing status, and that will trigger AMP to run. So yeah, as long as there's a passing status there, AMP is firing in the background. So now that AMP is actually running, if you were to navigate to File Explorer, you would start to see products dynamically generating there and populating for review. So in the bottom right there, you can see the folder structure. There's the case, the purchase, and then in this case, the draft firm database capture task. And you'll see that what's underneath that is what AMP automatically generated, which is the RFirm subfolder. And that's where the products that AMP generates are stored. So a couple things on the left here in this bulleted list. So you'll see the RFirm subdirectory gets created. There's an AMP generation status.txt file. And when you open this, it has information that tells you basically, yes, AMP is running. It tells you when AMP has completed processing, and it tells you along the way, as it's producing panels, as it's producing and generating each of the panels in that data set, it tells you if any of those panels failed during processing. So you know exactly which records may need investigation if you have to go back and edit the data set. And then you'll also see what's most important here. The whole point of the project is that it's generating the actual PDF or PNG firm panels and the firm index. And so all of that is available for your review on File Explorer, essentially in the same exact location that you would have stored them previously. So for AMP labeling and symbology, one of the big benefits of AMP is that it has a standardized set of logic for both labeling and symbolizing the features on the panels, and then for all the information that's populated in the title block as well. So all the specs that we've used for populating these panels, all the things that drive the look and feel of these panels are derived from the guidelines and standards and from the technical reference documentation that's been published. So as I mentioned in one of the previous slides, we use Esri's ArcGIS Pro software. We specifically use a Maplex labeling engine, and that gives us a little more customization and advanced control over label placement. And again, a big advantage here is that because we have systemized automated logic for every panel and index that gets generated, there's a predictable way that these panels generate, and it's always based on the attributes and the domains that are populated in the firm database. So one of the big benefits that we've realized from AMP is that the panels that get generated have a really consistent look and feel, and it's pretty easy to diagnose when you see a problem on the panel, if that's a data related issue, and then you can update the attributes to control that and basically rerun it to get new panels generated. So another aspect to AMP that was added prior to the release of the solution in early January is that it creates a firm index now. And this really gives a more comprehensive look at the panel coverage across the entire study area rather than just the individual panel. And it's a good way for users to get oriented, to get a better understanding of where their panel of interest is relative to the overarching study area. And same thing applies here as applies to the firm panels. The firm index, it relies on the data in the firm database, and it's generated in a consistent manner based on that data. So I put together a slide here. It's only been deployed a few months now, but I did want to spend some time covering some of the useful tips and tricks and covering some of the common questions that we've gotten to this point based on users that have directly interacted with AMP. So for starters, users have the ability to opt out of AMP if the project that they're working on has a case number that's prior to FY20. So there's an option you would see on that data capture task that I showed on an earlier slide. There's basically just a radio button for any pre-FY20 case that says, do you want to use automated map production? And it allows you to opt out. In which case, if DVT passed, nothing would happen. However, the expectation going forward is that any FY20 case or greater are expected to use AMP unless you've clarified with FEMA and you've gotten an exception to not use AMP. So FY19 or less, you can opt out. FY20 or greater, you're supposed to try and use AMP. Repeating the cycle, AMP does not have any limit on the number of times it can be run. So you can pass DVT on your data set, you can navigate to File Explorer, you can review the panels that were generated. And if there's something that you see there that needs correction, then you can go back, edit the firm database, and then re-upload it, run DVT a second time, and then that will trigger AMP again. And it will just overwrite the original set of panels that it produced. So it's an intentionally cyclical, kind of repeatable process that you can follow to continue improving the panels and the index just by virtue of continuing to update the firm database. AMP has to know which panels for which life stage of submission should be printed. And in order to do so, it looks at the predate and the F date fields that are uploaded in the SFirmPan table. So for a draft submission, AMP will print panel records that have null predate, null F date. For prelim, it will print those panels that have the highest non-null predate. And then for pending, or what I have as final here, it will produce the set of panels that have the highest F date. AMP does not generate FIS report tables. At this time, AMP uses the USGS National Map Imagery Service as the base map for all of the panels that it generates. So at this time, we're not switching to local community supplied data when we generate those panels. AMP will use GCS by default, but AMP does have the capability to reproject panels based on the projection value that's provided in study info. So if you have a state plan projection or you have a UTM projection, for example, that you want to use, as long as that value is populated in that projection attribute of the study info table, AMP will reproject those panels on the fly as part of its generation process. And then, sorry, my webcam is covering up part of this, but AMP does not require any changes to how mapping partners and regions conduct their QC or edit processing. So I won't spend a ton of time on this slide, but in addition to the development that we've done on automated map production in parallel, because DVT is the passing trigger, or because DVT passing is the trigger for automated map production, we've also been making some updates in parallel to the QC. So As you can see on the slide, we've added a check that specifically looks at the life stage of the data that's been uploaded and checks the way those predate and fdate fields are controlled, are populated, because that's kind of delicate for AMP. And that really helps facilitate the upload of data that AMP is capable of working with. The new RiskMAP IT help desk email address is now allowable in the metadata. And I also wanted to have that here just to bring up the point that any issues or questions or feedback that you might have as you interact with AMP, submitting a ticket to the IT help team is always a great way of getting feedback on that. And then if it's something that they can't get to immediately, then that gets escalated usually to myself or one of the other SMEs on our team. So that IT help desk email is a great resource for providing feedback and getting any questions, any specific technical questions that you might have answered. And then I think the other one there that is actually slightly outdated at this point, because we just released this past weekend, is we made some changes to DBT to accommodate the version 7 firm database schema. So there were some new allowable domains. There were some minor field length changes and some field population requirements that changed in the December 2020 version of the tech ref. And we just this past weekend released an update so that those version 7 firm database values are now checked in DBT properly. So in summary, some of the benefits of AMP are that we're really freeing up time in the sense that manual intervention and manual cartographic editing is no longer necessary because those panels are produced completely dependent on the data that gets uploaded. We'll see less of a need for alignment checks between the firm database and the panels that are generated. And again, the look and feel of the panels will be consistent across all the regions. More time can be spent on data development activities and refinement of data. Project costs, FEMA estimated, will decrease by $5 to $10 million a year. The turnaround of projects should be made faster just because this process is now automated, which means more data getting to the public more quickly and ideally encouraging more mitigation in that sense. And then lastly, again, consistency of symbology and labeling on panels should make the risk communication that goes out more straightforward. So now that AMP has been deployed, we are continuing to optimize it based on the great feedback that we've been receiving from FEMA's mapping partners and the users of the MIP. But we're also now starting to shift gears a little bit and look into another side of the operations outside of studies, which is revisions and revising effective maps. And we see a lot of the same opportunities here that we did when we conceptualized the idea for AMP studies. So basically, to be able to start automatically producing map attachments to be associated with this LOMAR GIS data. So less offline process management. We have the mapping information platform that I mentioned, which is already leveraged today for storing data associated with these LOMARs. And eventually the goal would be to take this LOMAR GIS data that is uploaded to the MIP and then start sewing it directly into the national layers to really reduce a lot of the manual effort that enables that today. So this AMP MT2 project is really just getting kicked off, but I'm also really excited about this project and I'm really excited about just continuing to explore opportunities to apply technology and automation where possible to enhance areas of FEMA's operations and make them more efficient. So thank you everybody for listening. My contact information is on the right there, and Andrew, who's the project executive on the RiskMAP CDS programs, contact information is also there. On one of the previous slides is the IT help desk email. So any of those can be used for sending us feedback or questions after the fact. And again, really appreciate everyone's time, and thanks for listening.
Okay, thanks, Jack, for that awesome presentation. So it looks like we have 2 questions that came in so far. So one question was from Susan, and she said, how can I find more information about AMP? What resources are out there to explain the tool?
That's a great question. I think one of the best resources that is out there right now is if you navigate to the MIP, there is a tab, there's a section called MIP User Care. And underneath that, additional resources. And there's a document there called the AMP Best Practices document. And that has a whole host of information on a lot of the more nitty gritty of AMP. It has information about specifically which attributes are used in the firm database for populating the features on these panels. It has information about how the title block gets populated, what triggers in the MIP kick off AMP, and just a lot of general useful information that you can use. So I highly recommend that AMP best practices document if you're looking for more information. And if you just have general questions that document does not answer, then you can always come to me directly with any questions as well.
Thank you, Jack. So another question, will AMP generated panels be held to a different level of quality than before?
So the short answer to that is we still want to target the same level of quality as before AMP was released. I think generally speaking, having seen lots and lots of panels generated by AMP at this point, there are occasionally scenarios where you may have a lot of critical features that are clustered in a really small geographic area. And in that case, there's the possibility that you may see a small degree of label overlap, for example, that wasn't there before because you had the opportunity to do some manual editing. But generally speaking, we still have the same standards of quality for those panels. And there's actually conversations underway right now to review some of the quality review checks. I think QR5 specifically looks at alignment between the firm database and make sure that the firm panels that are produced align to that data. And because, as I mentioned throughout the presentation, because AMP is directly using those values in the firm database to populate those panels, and there's also system restrictions in place that prevent you from making edits to those, it's kind of a system guarantee that the products that AMP generates are always directly derived from the firm database. So that really helps, that automated process helps ensure that you don't have misalignment that we might have seen in the past between those.
Thank you. Okay, so another question, what if my AMP case is FY 2020, but requires an exception? How do I get non-AMP panels on the MIP?
So this is where it does get a little bit tricky, just because the expectation is that any FY20 case does use AMP, and the MIP and AMP are designed in such a way that kind of enforces that. So there are some scenarios where you may need an exception. For example, we've had some users that, although the case number is FY20, the actual funding for the purchase and for the task and the actual work started in the year 2019, even though their case number is FY20. And so in those cases, if you have a valid reason for an exception, you can either put that in the IT help ticket, or you can reach out to Beth Norton, who's the FEMA product owner and oversees this process. And so long as the exception is granted, then the RiskMAP IT help desk is the best resource for ensuring that your manually generated panels don't get overwritten by AMP.
Thank you. Okay, Jack, we have another one. So firm database shape files are uploaded in GCS, but is it possible to generate those panels in the study projection, like state plane or UTM projection?
Yes, so that is where this study info table that's in the firm database has a value called projection. And as long as what you're using there is an allowable projection value that's in there's a 2020 domain table technical reference document that FEMA has published. And as long as the projection value that you use is in that domain table, we're able to take that and then reproject the panels that AMP generates on the fly to use that.
Okay, thank you. Are there any other questions? If so, feel free to send it in the chat. I think we have a few more minutes. Okay, it looks like one just came in. So, one second. Is the timing of when prelim pending / final panels make it up on the MSC any different as a result of the AMP?
No. So AMP, the timing of the publishing of products to the MSC still remains the same as it was before AMP was deployed. So no changes to that timing.
Okay, thank you. All right, anyone else? Just send the questions through. Okay, what is the best way of providing feedback on automated map production, and how do those updates get incorporated?
So a couple ways. I think one of those is through the IT help desk that I mentioned. If you send them a ticket and you have an issue that you've seen, or you have specific feedback or suggestions, that always comes back to us. The other way is just directly reaching out to myself. Dan Horner is another great resource in SME that was a huge contributing factor to this project. And then Beth is our FEMA product owner who oversaw the whole development of this project. So sending feedback directly to any of us is a great way to get feedback, and then to our IT help desk as well. And then as far as the turnaround for when that feedback gets addressed and actually implemented in the system, it basically we get that feedback, we translate it into user stories or defects, and we review those with the FEMA product owner. They're subsequently prioritized, and then they're included during our planning for development sprints. And one of the changes within the past couple of years for the RiskMAP CDS program is we used to be entirely waterfall. So a lot of requirements up front, and then 2 or 3 months down the line, the product would later be deployed. But now we're following an agile development sprint cadence. So every 2 weeks, we have a new set of stories, we have a new set of functionality to implement, and our ability to release things into the production environment is a lot faster. So anytime you have production, or anytime you have feedback for us, the short answer is that gets translated into work items. It gets included in our backlog to prioritize against FEMA's other work. And then it eventually gets included in our development sprints and released.
Okay, thanks, Jack. I think it's going to be time to wrap up. Do you have any last comments for our audience today?
Nope. I really appreciate everyone's time, though, and I hope the presentation was valuable. And again, if you do have any feedback for myself or for Andrew or Rob, please do feel free to reach out, and I'll be happy to get back to you. Thanks.
All right, thank you, Jack. Next up, we have Johannes.
Thanks, Ashley, and thanks, Jack. That was a great. I know a lot of people were interested in the AMP updates. Based from last year, here we are again, 12 months later, and made a lot of progress there. And again, if anybody has any comments or questions, send them our way. And even post-show, you can ask, and we'll get you in touch with the right people and have a great discussion regarding AMP. So. Appreciate that. And next we'll go into Dr. Johannes Schmude's presentation regarding, what's known as IBM pairs or / the Weather Operations Center. And he's going to be discussing some geospatial abilities and our geospatial big data platform, which is part of the Weather Operations Center, and then how you apply that to large scale geospatial problems. This rings true to flood mapping and the exponential growth of data volumes with resolution and hundreds of layers of underlying data. So I think this is going to be a great presentation. And Dr. Schmude is a research staff member with IBM Research. He's part of our IBM Watson Research Center. He leads our efforts for IBM around geospatial big data. And when he's not trying to solve these problems, and of course, hopefully beyond a pandemic, he usually enjoys seeing the world on vacations, and that's led him to stints living in Germany, the US, England, Wales, Japan, and Spain before finally sitting here stateside. So we're glad to have Dr. Schmude on this to present some updates and some potential around this solution, and look forward to hearing more. So, Dr. Schmude, I'll turn it over to you.
Hi, thanks for the introduction, and obviously, thanks so much, everybody, for attending the session. Also, obviously, thanks for the opportunity to present. Indeed. So, what are we going to talk about the next couple of minutes? So as said in the introduction, we're going to take a bit of a step back, okay? And that means we're going to take a step and sort of extend a bit our scale, both, just in scope. We're going to look a bit beyond, flooding to geospatial problems in general. We're going to also extend sort of the scale just to much larger amounts of data, whether the resolutions are much finer or whether you want to cover the entire globe or both. So we just basically take a big step back and talk about geospatial analytics in general. Okay. So what are the problems we're addressing in geospatial? There's some fundamental problems usually these days, no matter what you're doing, okay? And before we go into the problems, let's sort of set the stage a bit, and sort of define what do we talk about when we say geospatial. And I'm sure everybody here is sort of aware of this, but it's still good to keep in mind how heterogeneous geospatial data and geospatial data sets are, okay? So what we have on the one hand here on the very left is MODIS. Technically speaking, it's actually an NDVI image generated from MODIS data that we pulled out of our platform. Obviously, there's weather. It's a big part of geospatial data. I think this is here from ECMWF's high resolution forecasts. There's land use data, and there's also things like LiDAR. And to say a few things about this, and there's obviously many more examples, but I think these are somewhat representative. Most of the data I'll show you is raster data. The land use data, in principle, also can be vectorized. When you look at the LiDAR data, you see a key point also. So what you see here actually is from one of our partners. These are LiDAR images, and then from that extracted is other locations of power lines, okay? So obviously you have to be precise when you work with this, okay? So when you overlay this on a map as here, if your alignment doesn't make sense, your data is essentially useless. Okay, so when you work with these things, no matter what the problem, there's one fundamental problem, which is the data is very large, okay? So how large is large? What we have here is, this is a satellite image from Sentinel-2, okay? European Space Agency has 2 satellites in the Sentinel-2 program, and they generate about 3.2 terabytes a day, okay? So that's just Sentinel-2, depending what you're working on, you might say, hey, you need other parts of the spectral range, you maybe need SAR, that means you get Sentinel-1, maybe you want to work with Landsat, which is going to get you similar volumes. Maybe you care about higher frequencies or lower revisit times. You throw in MODIS, and immediately the volume of what you need to process and what you need to store grows a lot. Okay.
Hey, Dr. Schmude,
yes.
real quick, this is Rob. Your slides popped up initially and then they went away. So just want to let you know.
My slides went away. That is not good. I'm very sorry.
Yeah,
Let's
no
try
problem.
this again. Let's try this again. So
I'll let you know when I can see them again.
Can you see them right now?
Not right now.
All right, let's just do this. Okay, let's just like leave them like this and do the other solution. Is that okay?
Appreciate everybody. I know we're all doing virtual. Looking forward to hopefully next year seeing everybody in person in Orlando, I believe. So.
So thanks. I don't know what happened there. Okay, but let's just leave it like this for better to have something visible than something else. All right. So just as said, we had Sentinel-2. Looked at this nice image from Sentinel-2, but then actually satellite images is not even actually that much in volume. Okay. So my favorite one of these is always European Center for Mid-Range Weather Forecasts. And these guys generate, I think, 250 terabytes a day. Okay, I think out of this, like 50 terabytes are sort of considered as highly valuable operational data. The rest is also useful. But these are sort of the first problem is simply one of scale, just dealing with this. Okay, so there's a bunch of other problems that you have no matter what you do in geospatial. One is sort of, how the data is being stored. This is changing, but, traditionally and in actually most systems people work with, the data is being stored in some form of scenes, okay? In a worst case on tape that you really have to order it. Sometimes, on spinning disks, it takes obviously always time to assemble the data. Even if the data is stored in some sort of faster way than just, on something as slow as tape, you have a common problem that basically your different data sources are on different ends of the globe. You have like, satellite images from the European Space Agency, together with, weather from ECMWF, together with satellite images from NASA, is already on 3 different parts of the internet, in different projections, in different formats, et cetera, So often when you work with geospatial, you spend most of the time sort of setting up some data pipelines, okay? And that limits, the time to insight, especially when you're not even sure which data do you want to use. When you say, hey, do I use Sentinel or Landsat? Do I use maybe both? You say, which weather forecast am I throwing into my models? Similar things, what I said before is, as I said, you have different also geospatial projections, different grids, different resolutions, and then, so the second common step in these data pipelines is often sort of, reprojecting, normalizing things, assembling things, especially if, you want to run simulations on this data, but also if, it's 2021, you want to run some machine learning workload, some AI stories, something like this. Okay. So that's where we now come in as IBM, okay? So what we say essentially is, instead of everybody running their own data pipelines and assembling their own things, is sort of what we do is with this project called Pairs, we assemble the stuff that is hard to assemble, okay? And we bring in everything that lots of people need. And then this platform, is now called the Weather Operations Center, started in research as Pairs. You can bring in your own data and analyze these things jointly, because the first thing you want to do once you have a lot of data in one spot is you want to analyze it without moving too much, okay? So you basically, you still has no slides. Sorry, this is, let's see, share screen. How are we doing now?
There we go, great. Yep.
I'm incredibly sorry, okay? I think I know what happened, okay?
No,
can we see them now? All right.
You're good.
So what we have, in Pairs, we have 6 petabytes of curated data. You can bring in your own data. There's integrated analytics, some AI capabilities, okay? And this is sort of fully commercialized via IBM Weather Operations Center. So they started in research. I'm in research, I'm talking for research. But obviously this is now a commercialized product, so you can work with research, you can work with the commercial side. So the nice thing is, things you can do once you have all this data in one place, you can query it. So questions you can answer with Pairs is like, oh, I want to see satellite images for areas where the amount of rain the last week was 80% above climatology. That's something you can do. You see already, there's essentially 3 different data sets in the sentence, okay? There's some satellite image, could be, Sentinel, could be Landsat. There is, recent precipitation, could be, IMER, could be, some analysis data set, could be maybe chirps. And then historical averages, some climatology. And you're blending all these things together without doing any extra work. Okay. So I'm going to show you a demo now to show you what this stuff looks like, in the real world. that's maybe a good time to sort of take a step back and think whether you have any questions. Okay, so if you have any questions at this point, please, write them down, take a look, submit them. We're going to answer them later. And so let me now launch a live demo. So I hope you can still see my screen, because it would be really a shame to not show a demo where you cannot see things. So what are we looking at here? This is now the web interface to pairs, or to the Weather Operations Center. You see here IBM Weather Operations Center. So this is the commercial version. Obviously, the system itself is a cluster. There's API access, there's programmatic access, especially for data analytics. You would generally do API requests if you want to sort of do complicated things. But obviously, for demonstration purposes, it's nice to sort of show things which are visible, especially if the screen sharing is finally working, which I hope it now is. Okay, so in this story, what are we looking at here? This is something we did early on with clients of ours. What are we looking at here is a map generated by the US Department of Agriculture. It's the Cropscape map. So this tells you what has been planted in the US where. Okay. And this is, in many cases, very interesting. So if your business is in some case exposed to commodity prices, especially to agricultural commodities, then knowing this map is very valuable, especially for you want to ask questions like how much corn has been planted this year, how much soy, things like this. And it's nice. Just looking at the map, you can see, why the Corn Belt is called the Corn Belt. So what your business might want to do is, obviously when this map is released, it moves markets. So one thing that would be interesting for you is knowing this map ahead of time, or maybe running some other analytics on it or against it. So the first thing is, let's look at the Corn Belt here, but in detail. And let me do it slowly in case there's some lag. So obviously you can zoom in. I think the underlying data has sort of resolution of 30 meters. And as you can see, yellow is corn, green is soy. You really see why it's the Corn Belt. And a map like this is not static. This changes every year. Indeed, when I click here somewhere, there's a request going back to the backend. And I get a time series at this point. Now, this is categorical data, okay? And you can see, here 1 is basically corn, 5 is soy. So you have to think about this time series just as points. Somebody here, planted corn, soy, corn, 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 soy, corn, soy, corn, soy. So in principle, there's other farms, I see other patterns. And it's actually nice because, you see everywhere you look, there's actually some human being behind this who made some decisions. And in some cases, like for the farm we look right now, it's not very hard to build a predictive model. It's very clear that this farmer here just rotates every year, the biannual pattern between corn and soy. Don't need to do additional things. But in other cases, it might be much harder, to actually get any sort of predictive capability out of this. And obviously, it's much harder if you leave the Corn Belt and you have more than sort of 2 crops of interest. Okay. So one thing you can do when you have a platform like Pairs, like the Weather Operations Center, is, hey, let's bring in other data to answer this question. Let's bring in other data to say what has been planted across the US or other parts of the world with remote sensing. So what you would bring in then is, for example, satellite images, okay? So what we have here is now, again, from the MODIS satellite image for the US, and let's stick for the moment, somewhere, if you look at the Rockies. So this is the NDVI value. As you know, this tells you roughly how much vegetation there is, okay, calculated from the satellite data, from the satellite image. And in the Rockies, this goes between -1 and 1, or I think between 0 and 1. There's not much happening. This is not surprising. Or in the Great Plains, not much growth, But if you go back to the Corn Belt, to the Midwest, you get these nice periodic annual patterns. That means you've hit a farm in the Midwest. It's very clear. And what happens every year is there's winter, maybe snow, maybe just nothing is there. Then something is planted, it grows, and it gets harvested. And the same thing repeats every year. Now, the shape of this curve is actually the fingerprint of the crop at this location. So, like some detective, the name of the game is, given the fingerprint, can I identify the crop? Now, the hard part, as I think most of you know, is the shape changes every year. It's an early spring, there's a late winter, there's a big rainstorm in March, maybe there's some flooding in the area, who knows what's going on, So you cannot just the fingerprint changes every year. And in this sort of approach here, the idea is, hey, can I bring in more data, more information to answer this question? And again, the nice thing is we have this data and it's accessible at a fingertip. So what is nice? For example, we have daily precipitation from Prism, okay? And again, this time series is going to fire up in a second here. You see it's a very different time series. This is daily data. I think we have this back to, 1980 or whenever Prism goes back. Typical pattern for precipitation data, okay? So then you bring in daily temperatures, okay? Again, just because you say this influences things, you see obviously the seasonality in the data. Again, you can explore the entire historic archive in real time very fast because it's not stored, on tape or something. It's stored as fast, easily accessible data. Good. So you can bring in these different things. I think we also have things, for example, soil moisture, where again, of course, there's vector data here. So there's soil moisture from various sensors. This is a sensor network that was deployed at some point. There is also water holding capacity, for example, okay, is relevant for these sort of models. Okay, good. So obviously now I just showed you the data, but I hope you sort of appreciated the fact, the speed in which we could get sort of arbitrary time series for arbitrary points, and we just sort of could retrieve data. And once you have all these things together, you can build a model. In these models, you essentially predict, what might be at a farm level or at a regional level, what has been sort of growing. And then you can aggregate this up and get a prediction, for example, for the corn yield average by state. That's sort of the prediction certain clients you are interested in, what you might be interested in if you're working in this commodity field. And, you can build data-driven models, or if you want to throw in some physics on top of this data. All right. So much so good. Let me stop here for a second and give you a chance to ask any questions that you might have. Okay, or submit any questions you might have. All right, very good. So then let's return to our presentation, okay, and talk a bit about the technology behind this, okay? So I hope you appreciate the point, as I said earlier. We have this massive cluster which is growing, where we have lots of curated data. We bring in new things depending, obviously, client interest and whatever projects are happening. And then you can bring in your own data, analyze these things jointly, and do things like we saw. Obviously, this extends beyond agriculture. Okay. So a few things to say before we sort of get to the question of flooding, of course, which is quite key. A few things to say about technology. So we're ingesting something like 20 terabytes per day right now. I think these numbers are changing, but this is somewhat sort of realistic. Then once the data is in the cluster, it's quite key. Everything is linked in space and time, which, in your words, is everything is on the same projection in the cluster and thus easily accessible. And all these sort of headaches you get with reprojecting sort of, fallout. What we do effectively is, if you think about the bottom here, we have a bunch of data providers. There's some commercial data. I said there's ECMWF, there's the Weather Channel. There's, certain clients have private data, which of course is kept strictly confidential and separate. There's data by NASA, USGS, ESA, etc. So then, the cluster itself, is then basically based on HBase and various other database technologies, and then there's certain analytics capabilities on top of this, because the key part is you want to bring analytics to the data. Now, to wrap up, let's say a few things, how could you apply this to problems in flooding, okay? And let me say sort of up ahead, my expertise is really in geospatial at large. So I think, I'm sure, some of you, all of you will have much, much deeper knowledge on flooding, but, there's colleagues of mine who've been thinking about this at IBM. So the first thing to think about, is sort of, for us, when we think about geospatial, is always the data. It's always the content. That's the most valuable things. So let me tell you about, some data sets we have that might be interesting for your various applications. So there's a whole bunch of weather data sets. There is the ERA5 reanalysis from Copernicus. There is a proprietary IBM data set called Currents on Demand, which is a sort of near real-time analysis at 4-kilometer resolution. For precipitation, there's CHIRPS and IMERC. We saw PRISM a second ago. And then we're bringing in more and more weather forecasts. There's the ECMWF high resolution model. We just brought in the ECMWF ensemble, at least a part of that. There's the GFS forecasts. There's some data from HER, etc. Okay. Then a very different category, satellite imagery, aerial imagery. There's the Sentinel satellites. I listed more this year from NASA. I think we have Landsat. For aerial things, the USDA releases the SNIPE program, which aerial images of the USA. Things like this, and there's land cover. Now, let's not get to the point of flooding, okay? So colleagues of mine at IBM, started thinking about, since we have these geospatial capacities, how can we apply this to the problems of flood models and flood mapping? Okay, and the point is here not so much to make newer or better models. There's other people in the community who are doing research in this, and we don't need to replace this. Because there is research efforts around this. The fundamental question is, can we give existing models more flexibility or more power? Okay, so the idea is roughly, if you run your models with pairs as a backend, using pairs as the data provider, for example, then you can quickly change different inputs. So let's say you want to say, hey, how does my model run when I use chirps versus Prism or IMERC or something? Okay, how does my model run if I go from historical analysis to weather forecasts? If I use an ensemble forecast, how does my model run on this? Can I maybe do validation against observations from the Sentinel program? And things like this. Since the idea is that since the data comes all in the same formats, comes all without having to rebuild data pipelines. Okay, the first idea is you can simplify model building, modeling, and simulation by having unified data structures that are based on top of pairs weather operations center. So that's what our colleagues did. There's a few more things to this, but let me sort of give you an overview. So my teammates basically then, built their work on pairs. They use pairs to get satellite imagery, precipitation data, obviously digital elevation models, which I forgot a second ago, land use, soil properties, all these things we have. And then to start, they have two different projects, okay? One is they built on top of this, they ran on top of this, the integrated flood model. That's a flood model that was developed by IBM some time ago, okay? So let's see, how does this tie in with these things? But especially with the scope of saying, how can I scale this to large areas? And what's the flexibility it gives me? And then there's another brilliant colleague of mine who is using satellite data, Sentinel 1 and 2, I think, to use this for flood mapping, okay, as sort of an AI-based project. Again, sort of as an idea of validation for these maps, And the nice thing, of course, is you can see, I have these two projects here in mind, this IFM model and this AI model, but you could see, in principle, we could run other models there, For example, if you have models that you would like to scale, that you would like to connect to these data pipelines, they could also stand here. Obviously, you could also just get the output of these models, but the point is, we simplify and scale the geospatial analytics by sort of having the power of pairs, weather operations center, and then computation capability in the IBM cloud. Okay, let me give you a quick look what these results look like to make this a bit more real. And for this, let me go back to pairs itself. Okay, so actually I queried this out earlier, in the great scheme of cooking shows where you say I've prepared something some time ago. But you see, this is actually the pairs user interface. When you don't look at these examples, you have queries, you have a button to create new queries. You can generate data out of this. You see, I played with transmission lines recently, because I was looking at transmission lines and how they're affected by certain risks. But then my colleagues, basically loaded the results of their models also to pairs to explore for us a little bit. Let's fire this up here, just to give an idea just what this looks like. So obviously they ran the model. We don't show you how the model runs, but the results, they used GMTED as elevation model, for 250 meter resolution. They threw in some land cover data, which is also they have. They ran this sort of, in Texas, obviously soil classification. And then in the end, when they ran this through the IMF model, they got basically a flood risk model, okay? So what you see here is flood probability, basically the likelihood of getting, flooding for more than, I think, 30 centimeters for 1 day of the month or something like this. Obviously, you see the way the model works is every area sort of that is covered by a lake is essentially 100%. So there's no surprise about this, when you play with this, use the opacity. But you see sort of this, point is this was deployed on top of our geospatial platform and therefore scales very nicely. All right. So much about the work of my colleagues. Thank you very much for your patience, and let's see if there's any questions.
Okay, thank you, Dr. Johannes. So here we have a question. Can we take these feeds from multiple data sources like state, local, and commercial? Yeah, so that's exactly the point. I think that's actually what I do. We ingest really data we think is useful or that people ask us for. And exactly for problems like this, where you say, you want to see how do these different data sources combine. So either you would say, hey, I want to try like a local source or a state or some commercial source. You want to see how good are they, or you even build a joint model where you bring in all three, depending on what your model looks like. But these are exactly the things we do to have this flexibility. Let me say another good example is
if you move across boundaries. The prison data I showed you before is only available in the US, and then maybe suddenly you want to deploy your model somewhere else. You trained it with Prism in the US, but now you need a global data set. So all these questions exactly sort of pop up, that you want to have flexibility to basically, if you use pairs, you can try these different data sets by just changing some ID number in your code, which data set you're using, and that gives you flexibility. You don't have to rebuild a new data pipeline, which takes you 4 weeks and then say, oh, it was worth it. It takes you just the time to change the ID in the code, and then you rerun your stuff. But it's exactly the point of what we want to enable people to do.
Okay, thank you. Another question, is this only for the United States or does it work across the globe?
No, excellent question. I should have showed you. So this is across the globe, okay? I gave you a US-centric demo. And of course, some of the data I showed you was only US-centric. The Cropscape data, because it's US Department of Agriculture, it's by definition US. The prison data is US as well. But for example, the Modis images were global. Actually, I don't want to show you this right now, but it's sort of a party trick. Because when I click in the map I showed you, the query is live. I could have clicked outside the image area for Modis. If you would have seen I could have showed you satellite images from Modis for the last 30 years, any country you wanted to, But let's skip this. But yeah, it's a global thing. Obviously, some data sets only be released for certain areas, But yeah, we try to be global.
Okay, thank you. Another one, can you bring in recent data and turn it into predictive analytics / dashboard for mitigation or response planning?
That's an excellent question. So that's really good. Yes and yes, okay. So with near real, so obviously we have historic data, we have forecasts, and we have near real time data. We have a slight overhead in processing because of processing we do when we ingest data. When you want to be near real time, I think maybe we can be as fast as I think we can ingest data and it depends on the scale. Let me not give you a number, but it's usually not a problem. Okay, say we have people who make trading decisions based on this data. They're concerned about the time, but depending on the volume, there's overheads. I just don't want to give it a number because it depends on how much we're ingesting. Okay, whether it's the globe at small resolution or just something small. But yes, so you can do near real time things, and then indeed, especially. So I was talking about pairs. This is geospatial analytics. But I told you this is part of something called Weather Operations Center. And you can see already what I'm going to tell you. So yes, part of making hazard maps out of this, in general, getting ideas of this is partially what is already there in Weather Operations Center, or what my colleagues are thinking about. Part of the idea is we're bringing in this flood knowledge now to think about how the hazards now sit on top of this, okay? And I think it would be great to have discussions with stakeholders in the field, how to best do that, how to best bring sort of risk maps, hazard maps on top of this capability.
Okay, thank you. Another question, is the Weather Operations Center a physical location? And if so, where? And is it possible to visit?
It's a data center, no? So, I mean, you have to have access to the data center. It's physical. It's there's a whole bunch. So pairs and walk, it's a lot of racks with servers. No, we don't usually take tours, but yeah, I think at some point I took my niece and nephew to one of our data centers and they were not very impressed. They were just walking through the servers. They did not care. So that was I think the only tour we've given, and it was not very successful. But maybe one day, if there's interest, we're going to get some tours.
Yeah, you'll have to take them back when they get older, and then they'll appreciate it.
They did not care.
All right. So how could the flood insurance industry utilize more of this capability?
Good question. And again, I think, let me not go too far out because, there's experts in the industry it would be good to have these discussions. I think from my end, I think there's different possibilities, okay? One is you're a large player, you run your own models, okay? But you say, for example, I don't want to have this own data infrastructure. So we have clients, they start scaling. This GIS has been around. We have clients, they do GIS for some area, then they make this bigger and suddenly they run this giant cluster for data processing. Why do this if we can do this for you, okay? So you could work with us to do your data processing for us, or with pairs, and do your scaling. That's a typical case for insurance where you just say, you don't want to build your own data infrastructure. That's the one extreme where you just get the data from us. The next thing is you have a model and maybe you want to deploy the model on top of this in the IBM cloud. So, now it's just really a model you devise. It's your model, but you don't want to run this yourself. You want to run this on our infrastructure with our data, and again, you're profiting. And yet you have all the flexibility of saying, I have all the different data sets I can play with. I can do ensembles over forecasts or whatever you want, And the last thing is you say, hey, I actually just want to get a number, like a risk number, and that's we say we develop some models right now based on the model we have. And you might then, this is sort of research question right now, but you might just be able to get sort of like basically risk scores from us. So there's these 3 different things depending on your appetite of doing your own thing or just sort of getting the answers from us. I think, yeah. But it's good to have those discussions, I think, with, very happy to have those discussions with you if you want to know about this, because I think it's good for us to know what we in research should develop, for the market.
Okay, it looks like we have one more question. So you just mentioned that this could run models fairly quickly. Can you deploy this function as a disaster happens and help make operational decisions during response?
It's something we're thinking about. That's something we're thinking about. I mean, it's a good question, I think. I'm not sure. Okay, so there's a bunch of questions, of course, because when you think about this, like how much spatial precision do you need? Do you really, when we take up decisions, it's something I need maybe to learn a bit also about what decisions people are making in this area. But I'm sort of curious. My first question would be, what are the time scales and length scales we need there? So I don't have a good answer, but I think it's something, it's something good to think about for us, whether it's capable.
Okay, thank you. I just want to give it another minute. Does anyone have any additional questions they can send through right now? Okay, I don't see anyone. Dr. Johannes, any last minute closing thoughts? Thank you again for your presentation, but any closing thoughts?
Thanks for your time, obviously, especially thanks for your questions at the end, and if you have anything you would like to discuss, I did not share my contacts, but they're out there, so please reach out.
Okay, thank you very much. Turn it back to Rob. Do you have any last minute closing thoughts for the group?
Yeah, thanks, Ashley, and thanks, Dr. Schmude. My mind was going through a lot of different things there, watching that again, and I've seen it a few times before as we're progressing this technology, and I can think of a lot of different applications for it as well. So I'm looking forward to learning more as it progresses, and trying to find some use cases for it for sure. So I'd like to say thanks to Jack Paxton for the automated map production update and status. That was great, and I know it rang true through a lot of the attendees today. And again, to Dr. Schmude on the update on the geospatial analytics platform, and looking forward to talking more about that. I'd say if anybody needs to contact us, Ashley and I are working our booth. Feel free to send us questions there as you peruse the virtual show. And if you need to reach out, I think most of y'all know either Andrew Dipmore, myself, and a few others on our FEMA programs. So definitely touch base with us, and we can set up further discussions, whether it's around the geospatial analytics or more on the automated map production. We're happy to host those conversations, and we appreciate the ASFPM show this year and the support they've given us, and we look forward to hopefully having a in-person year next year, and meeting everybody face to face. And again, thank you to everybody. And if you have any questions or comments, reach out to us, and I look forward to a couple more days of the great show and some more sessions. So have a good one, everybody.